Let's define the chain rule and then use it in a couple examples. So the definition of the chain rule is going to be, let's let f and g be functions. For all x in the domain of g where g is differentiable, but we'll talk about those kinds of things later. The derivative of the composition h of x is equal to f composed g of x, or f of g of x. The derivative of the composition is going to be h prime of x is equal to f prime of g of x times g prime of x. And we learned a couple different ways of notating the derivative, so let's do an alternative definition for the derivative. Alternatively, if y is a function of u, and u is a function of x, we could say that dy dx, the derivative of y with respect to x, is going to be equal to du let me go back. It's going to be dy du times du dx. And we'll use this definition a little less, but the definition above is the one we're going to go with for our class. And let's do a few examples. So let's say example 1. Let's look at the function h of x is equal to 1 over 3x squared plus 1 squared. And let's identify our f of x and g of x. So in our definition up here, we have h of x is equal to f of g of x. Okay, well, in this case, our f of x, our outer function, is going to be 1 over x squared, because we have 1 over something squared. And our g of x, our inner function, is going to be the thing that is inside of that square, which is just 3x squared plus 1. And what did we see up here? We saw that the derivative of f of g of x is going to be the derivative of f with g inside. So let's look at that. Let's take the derivative of f and then put g of x inside. Well, the derivative of f prime of x, is going to be equal to, f of x is equal to 1 over x squared, which can be rewritten as x to the negative 2. And we know the power rule. The power rule is just that we can bring the negative 2 down, x to the negative 3. Awesome. That's the derivative of f of x. And our definition says the derivative of f with g inside of it. So our first piece of h prime of x is going to be negative 2 times, instead of x, we get g of x, which is 3x squared plus 1 to the negative 3. That's our first piece. We still have another one that we need to get to, and that other piece is just multiply it by g prime of x. Well, we know that g is 3x squared plus 1, so the derivative of g is just going to be 6x. And that's our chain rule. Our chain rule multiplies these two things together, and what we're left with is 6 times 2 is 12x times negative 12x times 3x squared plus 1 to the negative 3. And now there's an easier way of thinking of these things, which let's do this example again. Let's say h of x is equal to 1 over, it was 3x squared plus 1 squared. There's an easier way of thinking about this. So instead of using the direct definition, you can use the direct definition like we just did and get the answer. Or you can say we have the derivative of the inner function multiplied by the derivative of the outer function. And we can use that second notation to say this. We can say something like this. Let's let u equal 3x squared plus 1. u is equal to 3x squared plus 1. Then du dx, the derivative of u with respect to x, is going to be 6x. And if u is equal to 3x squared plus 1, then h of u, instead of h of x, is going to be 1 over u squared. Which again we can say is, okay, that's u to the negative 2. And then we can take the derivative and we can say h prime of u is equal to negative 2 u to the negative 3. The derivative of h with respect to u is going to be negative 2u to the negative 3. And then we can just plug everything back in and multiply things together. So from here we can say, okay, then the derivative with respect to x is going to be negative 2, replace the u with what we have here, 3x squared plus 1. But we have this du dx that has to tack on to the end, which is 6x. And, oh, this is to the negative 3. And we're left at the end with negative 12x, 3x squared plus 1 to the negative 3. If you're still confused, I definitely suggest trying a few examples. So let's do an example, maybe an easier example. H of x is equal to, this is going to be example 2. H of x is equal to 2x to the third power plus 2x minus 1 to the fourth. And I'll show you how quick the chain rule can be. H prime of x is going to be the derivative of the inside function. The derivative of the inside function here is 6x squared plus 2. And we're multiplying that by the derivative of the outer function. Well, the derivative of the outer function, we're going to keep the inner function the same. We get 2x cubed plus 2x minus 1. And the derivative of the outer function, the derivative of something to the fourth power, is that thing to the third power multiplied by 4. And that's it. That's how simple the chain rule can be. If we do this problem in the longer way, we can say, let's say f of x is equal to x to the fourth. F of x is something to the fourth. G of x is 2x cubed plus 2x minus 1. The derivative of f of x is 4x to the third. The derivative of g of x is 6x plus 2. And then we just get the derivative of h of x is equal to the derivative of f of g of x, the derivative of f of g of x times the derivative of g of x. And then we can just plug those pieces in. We have f prime of x is 4 times something to the third power. That thing inside is going to be g of x, which is 2x to the third plus 2x minus 1. And then the outer function, or the derivative of the inner function, the g prime of x, is just 6x plus 2. And that's all there is to it. So let's do a slightly more complicated example. Let's say example 3 is, let's find the tangent line to h of x equals 1 over 3x minus 5 squared, specifically at x equals 2. So we have this function, we don't really know what it looks like, but we want to know what the slope of that function is right at the point x equals 2. Well, we can start by finding what that point is. We can say when x equals 2, h of 2 is equal to 1 over 3 times 2 minus 5 squared. 3 times 2 is 6, minus 5 is 1, 1 squared is 1, 1 over 1 is 1. So x equals 2, y equals 1. And then we can find the slope by finding h prime of x. And h prime of x is going to be the derivative of the inner function multiplied by the derivative of the outer function. And the derivative of the inner function is just 3x minus 5. Let's do this in the long way. Let's say f of x is equal to 1 over x squared. G of x is equal to 3x minus 5. We know immediately g prime of x, that's the easy one, that's equal to 3. F prime of x is a little more complicated, but we can do that same thing we did before. We can say this is equal to x to the negative 2, and then just do the power rule, which is negative 2x to the negative 3. And so h prime of x is going to be the derivative of f with g plugged in for x. So this is going to be negative 2, 3x minus 5 to the negative 3, multiplied by g prime of x, multiplied by 3. Okay, we have our h prime of x. Let's find our h prime at x equals 2. H prime of 2 is negative 2 times 6 minus 5 to the negative 3 times 3. Well, 6 minus 5 is 1. 1 to the negative 3 is still 1. Negative 2 times 3 is negative 6. And so what did we just find? We found our slope. So going back up, we have x equals 2. Y equals 1, and our slope is equal to negative 6. From here, we can kick it back to algebra and just say we know the line that touches at this point is y equals mx plus b. We have mx and y, so we have 1 is equal to 2 times negative 6 plus b. 1 is equal to negative 12 plus b. And specifically, we know that our line is going to have b is equal to 13. So we get the line y equals negative 6x plus 13. And that's the line that touches this function at the point 2 comma 1. And so now we can do really complicated derivatives. We can take the derivative of almost any function that we've seen before. So let's do one more example while we're here. Let's say E4, our example 4, let's do a more complicated one. Let's say this is 2x plus 1 to the 5th times 3x minus 2 to the 7th. So now we have a product of composite functions. Okay, the derivative of this is going to be h prime of x is going to be, this is h of x. And this is a product rule. So we have the derivative of the first function, f prime, times g, plus g prime times f. And what's the derivative of the first function? Well, the derivative of the first function is going to be f prime here is going to be the derivative of the inside, which is just 2, multiplied by the derivative of the outside, which is going to be 5, 2x plus 1 to the 4th. And then we can multiply that by g to get our next piece. Our g prime is going to be, the derivative of that second piece, the derivative of this over here is going to be 3 times 7 inside 3x minus 2 to the 6th. Glue it all together, and what we get is f prime, 10, our h prime of x is equal to 10 times 2x plus 1 to the 4th times g, which is just 3x minus 2 to the 7th, plus g prime, which is 21 3x minus 2 to the 6th, got the 21 from the 3 times 7, g prime times x, x was just 2x plus 1 to the 5th power. And so we see that we can take the derivative of this function without multiplying this one by itself 5 times, multiplying this one by itself 7 times, and then multiplying them together, which would be essentially hundreds of terms. And so we can take the derivative using the power and the chain rule and the product rule. We can put all of our rules together and get an answer like this.